This is lesson 7.3, and we're going to talk about how to prove that a quadrilateral is a parallelogram. So in our last lesson, we talked about all the properties and the definition of a parallelogram, which all are able to show us if a shape is one. So the parallelogram opposite sides converse says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So if it's a parallelogram, they're congruent. If they're congruent, it's a parallelogram. Same thing with our angles. If both pairs of opposite angles are congruent, then it's a parallelogram. There's a key word in all of these converses that was not in necessarily to say in the definitions originally, and that's both. If I don't see both pairs match, it doesn't work. If I see one pair matches and the other pair is different, it doesn't work. So both pairs, same thing for our opposite sides, both pairs of opposite sides. The parallelogram diagonals converse. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So if this piece matches this one and this piece matches this one, then it's a parallelogram. This is the wrong picture, but we will move on. It's okay. So if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So what that would have looked like, instead of the markings in here, we would have a pair of sides congruent, and that same pair of sides is parallel. So you don't need to know anything about any of the other sides or anything inside. As long as I know this information, that's enough to say that it is a parallelogram. And our last one was the definition of the parallelogram. So if both pairs of opposite sides are parallel, then it is a parallelogram. So for our first example, for what values of x and y is PQRS a parallelogram? So we would know that in order for it to be a parallelogram, the opposite sides would be congruent. So we're basically going to treat it as if it already was one to solve for x and y. So here we can get x equals 10 by setting 2x minus 1 equal to x plus 9. And then if I set my other two sides equal, I know there's a different variable there, x plus 7 equals y. I just learned that x is 10. So 10 plus 7 equals y, 17 equals y. So here's a check-in. Pause now, try it. Answers posted on Google Classroom. All right, example 2, for what value of x is it a parallelogram? So we already know those two are congruent, so now these two would be congruent. 5x minus 8 would be equal to 3x. So I'll take 5x away. So negative 8 equals negative 2x. Divide by negative 2, and we get 4 equals x. Here's another check-in. Pause. Answers posted on Google Classroom. The only other kind of question we're going to do here is determine whether each quadrilateral is a parallelogram and explain our reasoning. So we know, I'm going to make a list of our possible reasons. Both pairs of opposite sides are parallel. We can have both pairs of opposite sides are congruent. We can have one pair of opposite sides parallel and congruent. We can have opposite angles are congruent. And we could have diagonals bisect each other. But since I don't even see any pictures with a diagonal drawn in here, I'm not going to worry about that one for right now. So in A, I see that I have 7 and 7, so these sides are the same. And I have 4 and 4, so these sides are the same. So these opposite sides are congruent, and these opposite sides are congruent. That's what I saw right here. Both pairs of opposite sides are congruent. So this is yes, and my reason is both pairs, opposite sides, congruent. For B, these symbols mean parallel. So these sides are parallel, and these sides are parallel. So what I see is here, both pairs of my opposite sides are parallel. In C, I see this side is 4 and this side is 4, so they're congruent, and they have the parallel symbols. So I have a pair of sides that's parallel and congruent, and that's what I see right here. And in D, I see these sides are congruent, these sides are parallel, so I do have a pair that's parallel and a pair that's congruent, but unlike it was in C, it's not the same sides. It was one pair of sides parallel, a different pair of sides congruent, so this is no, not the same sides. Parallel and congruent, right? It would have to be the sides that are parallel were also congruent for that to be yes. So here's 3 for you to try. You can pause now if you'd like, but this is also the end of our lesson. So this is how we prove or show that a quadrilateral is a parallelogram.